Welcome to Rival Institute. Now discussing the Fisher-Etsat test. So we know in last class we studied the contingency table. Contingency table. In that we have two variables, two categories of variables. So these variables are representing like that. So here it is a x1, here it is a s2. So this is a one category of variables, and we have a y1 and y2. So this is a other category of variables. So this is, we can write like that. So this is a one types of variables. Here it is a other types of variables. So here we can write the, what is the n type number of items. Here it is n x1 y1. So number of observations in this category, x1 with y1. So this category is x1 y1. Number of observations in y1 s2. This we can write s2 y1. And here it is a n s1 y2. Here it is a n s2 y2. So total number of observation in x1 is a n x1. It's a n s1 and n s2. So this is n s1 and n s2. This is a total observation in x1 category. This is total observation in s2 category. Here it is a total observation in y1 category. Here it is a y2. So total observation we can write it is a n. So this is a contingency table. So if it is values are higher, these nx1 y1 or ns2 y2, these observed values are higher, we will use the chi-square test. Chi-square test. But in some time we need some exact result. If it is a less than 5, this is some cells have the values are less than 5. That time we can use the exact test. This Fisher-Etsat test. When these values are lesser, so smaller values we can use we can write the smaller values of in any of the observation. We can use the Fisher-Etsat test. So this chi-square test is already studied in last class. In contingencies table we can make the expected values. So after that we will use the chi-square test. Now values are smaller, then we will use the Fisher-Etsat test. In Fisher-Etsat test we need to find out the probability of occurring in xy1. So this cell, what is the probability of occurring this cell? So that we can write s is equal to n s1 y1. What is this probability? So this probability using by hypergeometric distribution. So this is like a hypergeometric distribution, and probability is using this formula, hypergeometric distribution formula. So this one we can write n s1 y1. So this is the combination of n h1. This is number of observation in total number of observation n h1, and occurring in this cell is n s1 y1, and next is n s2. Total number is n s2. In that n s2 y2 whole divided by total number is n, and is occurred n y1. So in particular cell we have what is the probability. How to get the probability? By using the hypergeometric distribution ns1 y1 and ns2 y2, and a total probability. So this is where we can find out the probability value. So now we know how to calculate the probability value. We need to find out the p value. Then only we can test whether it is a hypothesis will be correct or not. Then what is the hypothesis? Here is a hypothesis is h0 is defined. H0 is saying that there is no association between the variables. There is no association between the variables, between these two variables. So that we can call as a independent. H1 will say there is a association between the variables. So these variables have some relationships, that we can say the alternative hypothesis. So this hypothesis, null hypothesis, always will say there is no relationship between the variables, no association. So these variables are independent. How to find out this independency? We need to find out the p value. So getting p value, we need to combinations, all types of combinations has to write. We have to make all types of combinations. So each combination we need to find out the probability. Each combination we need to find the probability. And all combination we are finding out first combination, second combination we need to find out probability, third combination probability, and fourth combination probability. We are calculating each probability of each combination. After that we finding the p value. P value is equal to this observed value. Here we will get some probability value. Here we get the probability value for this observation. This observed probability value, we can write the observed probability value plus some extreme cases, some extreme probabilities. These extreme probabilities will be smaller than observed probability, smaller than observed probability. So sum of the all smaller than observed probability, sum of the probabilities of all smaller than observed probability plus this observed probability. So this sum will be p value. That is a p value. This getting the p value, we can consider the p value with the p value. We know that it will be, if it is a 0 to p values is less than 0.05, we can reject the null hypothesis. If greater than, we can accept the null hypothesis. So this is the basic of the Fisher test. So Fisher test have the two variables and two categories of variables. We distributed like that: y1, y2, s1, s2, and the number of observations is written like that. So this is a total number of observation in s1 category. Here is a total number of observation in s2 category. Here is a total number of observation in y1 category and y2 category. Here is a total number of observation. So this table total will be n. Then we need to find out what is the probability of occurring this particular observation. So this is using the hypergeometric distribution equation of ns1. This is a total probability and is occurring is ns1 y1. This is a combination. This is like that. It is a combination ncr. It is like that, ns1c, ns1 y1, and this is ns2 y2. This is out of ns2, this is observation, and ny1, this is total probability. So total combinations. So we got the probability value. After the probability value, we have to find out the p value. Getting the p value, we need to write all the combination values, all combinations, extreme cases, below extreme cases, all cases has to consider. After that we need to add p value, means probability of observed probability equal or some extreme cases. That extreme cases will be lower probability than the observed probability. So we need to add this all probability, then we'll get the p value. Compare this p value, we can reject or accept the null hypothesis. So this is the basic of the Fisher HSAT test. We can take some example, we'll understand. For example, in a company, so one company is there. In that company, we have issued the share options, ESOP. We can call the ESOP options, ESOP. So we issued the ESOP for senior grade and junior grade. So we have a senior grade and junior grade. So we can write it is a senior grade and this is a junior grade. So we have a senior grade and junior grade. So in this junior and senior grade, this ESOP option is given. ESOP option is given for this both. So we have observed. So this observation, we have a 5 senior grade people are there and 6 junior grade people are there. We have 5 senior grade people and 6 junior grade people are there. So total people are 11. Out of that, 3 people we have given the ESOP options. So we issued only 3 people. 3 people we issued the ESOP. So in that, 2 people got the senior grade people got 2, and we observed that senior grade people got 2, senior grade people got the share option. So this is total 3. So here is a remaining 2 minus 5 minus 2 is a 3. 6 minus 5 is a 5. So total is 8. So this is total also is equal to 11. So this is the problem. Now we need to find out the what is the probability of the observed data. First we need to find out the what is the probability of observed data. So in observed data, this is a ESOP issued. So ESOP we can write even this S1 and S2 we can write like that. ESOP option is received. So yes, ESOP option is received. This is no. So senior grade we can write the senior grade senior SR and this is junior grade JR. So this is the case. So two ESOP option is given for the 3 people, and out of 3 people 2 senior people got the ESOP option and 1 junior person got the ESOP option. Remaining people not got the ESOP option. So this is the problem. Now we can find out the hypergeometric distribution. Using the hypergeometric distribution, we find out the probability of S is equal to NS1Y1. This cell we can write the probability of S is equal to 2. Here it is a NS1Y1. Here S is equal to 2. What is the probability of S is equal to 2? What is the probability of S is equal to 2? What is the probability? So we know that here our equation is NS1 NS1Y1. This is the formula. So NS1, we know this NS1 is a 3. Out of 3, we have NS1Y1. This is a 2. And this is a combination. Out of 3, 2 people got the ESOP. So 3 is a total number of received ESOP. Out of 3, 2 people got the ESOP. In next cases, out of 8, 3 people in senior grade not got the ESOP. So total number of people are 11. And in out of 11, 5 senior grade people are there. So this is the total senior grade people. So out of 3 senior grade, out of 3 ESOP, 2 people got the ESOP. In that senior grade, out of 8 people, there is 3 people are there. And total 11 people, 5 people are senior grade. So this is the probability. This probability will get like that. This probability is equal to 3, 2. So 3C2, and so this value will be a 3 only. We will get 3, and 8, this is a 3, and 8C3 divided by 11C5. So this value, if we are multiplying, we will get the value of 0.3637. So this is the probability value, 0.3637. So now we need to find out the combinations, all combinations. Finding out the p value, we need to find out all the combinations. So what are the combinations is available? So here is H0. H0 is no association between the ESOP and senior grade or junior grade. There is no association between ESOP is distributed in senior grade or junior grade. H1 is saying that there is some association is there in distribution. So now we can write all the combinations. How to write the combinations? Here it is a 2, 3, 1, 5. We can write the all extreme cases. We can say the all are extreme cases. So senior grade is there, junior grade is there. So this is a first extreme cases. We just write like that. So first extreme cases is 3 people, 3 senior grade. We will start with the 3. All people got the senior grade, got the ESOP. Yes, no. All people got it. Then here junior grade nobody received. And here it is. So this is 3. This will be same for every down. This will be same. 5 and 6, 11. So this will be same for everybody. All combination this will be same. So here only there are some changes. So 3 people got the, this is extreme cases. 3 people got the ESOP. Then remaining 2 is there. Here it is a 6. So this is a one combination. This we can say one combination. So here also we can find out the p value. So p value, probability value, not a p value. Probability of S is equal to 3. What is the probability of S is equal to 3? So same way, 3, 3 and 8, 2 whole divided by 11, 5. This 11, 5 is common. 11, 5 is common for all cases. and 8. So this probability is equal to 0.06, 0.0606. This is the probability. So this is a probability for x is equal to 3. And other cases, second cases, we are studying for the second cases. So second cases, second combinations, you can write like that same way. So this is a senior grade, this is senior and junior, and this is yes, no, and here is 3. Second case is the same. We can write 2, 3. We are just reducing this column only. We are looking this column, just reduced 1 and 3, 1, 5. So this cases we know that the probability is equal to 0. We already received 0.3637. We can check the third cases. So if the cell value is higher, you see, this is all combination has to check. So if this cell value is higher, the cell values are higher means we can't check manually all the combinations. Very difficult. So this cell values are less than 5. Here this is some of the one of the cell values should be less than 5. Then we can make all the different combinations. So now you see in third combination, here is a 3, here is a 3 is taken, 2 is taken, 1. So 1, here it will be a total 5, here it is a 5, here it is a 6, 11, here it is a 3, 8. Here 1 means here it will be a 2 junior people got the ESOP. Here is 8, so this is a 4. So this is a probability value. Probability value will count finding by the same formula 3 1 3 1 and 8 4 whole divided by 11 5. So same formula. This same formula is applied here. We got the probability of 0.4545. 0.4545. So we are taking the another one more cases, fourth cases. How to find out the fourth cases? Fourth cases is we can find out the fourth case. Here we considered 3 senior people got the ESOP. Here is a 2 senior people got the 1 senior people. Here is a 0 senior people. Then all junior people got the ESOP. So this is a senior. No one got the senior people got the ESOP. So junior people got the ESOP. So here it is a 5. So this is a 5, 6, 3, 8. So this is here it is a 3. So this is all combinations. Here probability need to find out the probability is equal to, we will get 0.1217, 0.1212 something will get. So now you see, we find all the combinations. Here it is a 4 combinations. This is observed value. This one we can write, this is a observed data. This is one is observed data. Here this is we are written the all combinations. Now all combinations is written, all combinations. Out of this all combinations we return the all the combination. One combination will be observed. This one is observed. This out of all cases one will be observed. So this one is the same like a observed data. Now how to find out the p-value? P-value is finding out the p-value. How to find out the p-value? P-value should be should be this observed probability same. Observed probability should be same or less than the observed probability. So whichever the observed probability and less than the observed probability. Here it's a less than the observed probability. So we can say this is extreme cases and this is observed probability. Here this value we can't take because it is higher than observed probability. So we can't take. Here this is a less than observed probability. So what are the p-value? We can take 0.0606 plus 0.3637. That is observed probability plus next is this one 0.1212 17 or something. So p-value is calculating observed probability. How to write the p-value? P-value is taken by the observed probability or extreme cases. We'll write like that. Observed probability plus less than observed probability. Sum of, we can write the sum of observed probability plus less than observed probability values. All values we have to take for the p value. So here is observed probability 0.3637. So we need to take the less than 0.3637. So this value also we have to take, and this one is a less than. So this less than is a smaller than observed probability, that we can call the extreme cases. So extreme case will be extreme case will be, what will be the extreme cases? This will be a smaller probability. Extreme case will be always will be a smaller probability. Here you see extreme cases, 3 senior people got the ESOP. Here this is extreme cases, 0 people. Here is junior 3 people got the ESOP. So all extreme cases, that extreme case will be less than the probability of observed probability. So we need to add this all probability. So that all probability, if you are adding, you will get the p value. So p value is equal to 0.5454. So this is greater than 0.05. So we can accept the null hypothesis. Null hypothesis H0. There is no association between the ESOP and distributed ESOP with the senior grade and junior grade. There is no association between ESOP is distributed between the senior grade and junior grade. There is no association. We can accept the null hypothesis. That means this ESOP distribution and senior grade and junior grade, these two variables are independent. We can say that is independent. So this is the example for the Fisher-Hessad test. Hope you understood about this Fisher-Hessad test. We have to write the observed data, find the probability, and we need to write all the combinations data and find the probability, then find the p value. P value will be observed probability plus all less than the observed probability. That all value we have to find out the p value, then compare with the 5% significance level. We are saying that if this is associated or not. We can accept the H0 or not. So that is the Fisher test. Thank you.